And my first speaker is Mrs. Özge Yilmaz, Ph.D. and Environment Industry Group Coordinator at Ekodenge. She coordinates the Nature4Cities NBS Environmental Impact Assessment. And it's important to understand not only the benefits, but also possible trade-offs when evaluating NBS projects. She is going to introduce you now to the Nature4Cities Project environmental assessment, combining urban metabolism, agent-based modeling, climate assessment, and life cycle assessment.
Good morning, everybody. Let me just arrange my screens for you. Here, yes. I hope you have the whole screen of the presentation. If not, please tell me so. So good morning, everybody. Again, it's very nice to see all of these people coming together for this virtual forum. So I welcome everybody. So thank you, Vera, for the nice introduction. My name is Özge Yilmaz. So I'm from Turkey, working with an SME called Ekodenge. And today I will be introducing you the Nature4Cities Environmental Impact Assessment methodology and the environmental assessment tools. So we have been talking about NBS a lot for the last 2 days, yesterday and today. So it's very well known among all of these practitioners, all of us, that NBS has multiple co-benefits. So it has environmental benefits, social benefits, economic benefits, of course, for the society, for the health. So a wonderful solution for sustainability. So here, what we are trying to do is first to identify the environmental benefits and quantify the environmental benefits as much as possible. And also, of course, there are many benefits of NBS, but there might be some trade-offs associated with the NBS projects based on the location or implementation or the NBS type itself. So as Vera already put into words, we need to consider both the benefits and traits of the environmental aspects of NBS. So in Nature4Cities project, we had a dedicated work package for the environmental assessment framework. And during this work package, we had a collection of different modeling and assessment methodologies that combined to provide this assessment framework. So the first part was dedicated to the use of urban metabolism approach for conceptualization of the NBS projects. And it was complemented by the life cycle assessment for quantification of the benefits and the trade-offs. We also had a dedicated task for the guidance on climate resilience assessment models for proper estimation of climate impacts. We had a very interesting study that included agent-based modeling to reveal potential links between NBS projects and policymaking. And of course, cities are always, transforming. They are very dynamic. So over time, a lot of things changes. So it's never a static system. So we wanted to include a dynamic assessment methodology to support temporal application of the environmental assessment framework. So let me start with how we wanted to identify and quantify the environmental impact. So of course, we wanted to bring in an indicator-based assessment to guide the decision makers for NBS projects. For the environmental part, we identified 2 types of indicators. The first one is the urban flow indicators that is assessed through material flow analysis. And in fact, this is where the urban metabolism approach was very helpful and supportive to us. So for the urban flow indicators, they are determined in the form of headline indicators for different NBS projects to be quantified by analysis of urban nexus. So we wanted to understand what's going on in terms of the material and energy flows by using urban metabolism approach, and put them into the context by using very relevant headline indicators for each NBS. So a streamlined urban metabolism approach is adopted to determine the system boundaries for urban flow indicator assessment. And these system boundaries, in fact, helped us to select a very relevant indicators for the environmental assessment. The second set of indicators was, of course, the life cycle indicators. The life cycle assessment and the urban metabolism approach, the conceptualization through urban metabolism approach, they share the same system boundaries. And of course, life cycle assessments helps us to understand many different environmental impacts, many different life cycle indicators all together, and helps us to quantify the benefits on a holistic basis and of course the trade-offs. So what we have done to study the urban flow indicators, so we worked NBS by NBS. So we had many NBS types covered under Nature4Cities project. So what we have done was we tried to understand the environmental benefits and trade-offs for starters as narrative sentences. So try to think about what can be the benefits, what especially on the environmental term, and what can be trade-offs. We also listed some urban processes and some urban flows or nexuses that are relevant to these impacts. You know, what we need to look at to identify or quantify a given benefit or a given trade-off. So that was the question, and from there we identified the headline indicators for each NBS. So from there, we try to come up with the system boundaries. As you can see, this is an example 6 system boundary for the living walls system application. So we have the inputs and outputs. Everything is in the form of material and energy flows. We have urban processes that are linked to this NBS project, and this helps us to quantify different indicators by looking at the changes in the flows, and it paves the way for the LCA process. The LCA, our vision was to provide complementary and detailed life cycle assessments specifically adapted to the requirements of a particular NBS case study. So it started by the environmental assessment methodology development, so how we are going to combine LCA approach with NBS. And then a lot of studies has been done on different NBS projects to provide generic life cycle inventories. And these generic life cycle inventories are, of course, very much connected to the urban processes and the urban flows that are happening around the NBS projects. Then the life cycle inventory modeling of NBS was achieved. There are, of course, certain links with the urban metabolism system boundaries, and life cycle impact assessment was delivered. Another important part is the climate resilience assessment. Different assessment methodologies were surveyed considering the links with NBS, and fact sheets were prepared for each methodology. The decision support guidelines were created with the aim of helping the municipalities or other decision makers in identifying and deciding between all the existing methods and tools to analyze the climate resiliency that is provided by the NBS projects. The tools with high applicability potential were identified during our study. As I said, these are always transforming. They are very dynamic. They are never static. For this reason, we wanted to introduce a dynamic assessment methodology. So it starts with the time frame and time resolution setting, the baseline data establishment, target setting, time series analysis, and the analysis of the trends. So the main idea is try to understand where the impacts or the benefits of NBS are going in trying to foresee with the trend analysis, with the regression analysis based on the data that we have over the years. So it starts with the implementation, and during the monitoring phase, we try to see if we are able to reach our targets in the given time frame and what is the expected benefits in an interim manner, let's say. So it's supported by continuous monitoring. It's very important. And the idea is for it to support the change from reactive to proactive evaluation for during the implementation phase. And as I said, a very interesting part of our study was inclusion of the agent-based modeling. So why we selected agent-based modeling as part of the environmental assessment framework? So first, there is a need to track people and behavior over time to understand what will happen in the future. Of course, people are differing, resulting in different behavioral manners. Learning from the past is important, so we need to bring in a framework to enable us to learn from the past experiences. Spatial information and impacts are, of course, critical, and networks between people need to be studied. So we are not talking about individual citizens, but we are talking about the society when it comes to urban sustainability measures. So we think agent-based modeling can help to understand upscaling of NBS solutions to larger areas of the city. Uh, the isolation of the particular parameters within the NBS projects and the flexibility to change them, see how they affect the results, deliver very critical insights for the future. So especially to identify particular benchmarks that could be requested from NBS in procurement or projects is one of the major benefits of the agent-based modeling. But of course, more work is necessary. Improved toolkits and integration of experts within the policy domain is needed. So this is an ongoing work, and it's very insightful and it's promising. So the first step is selecting the NBS model. The second step is selecting the specific type of NBS that you will be doing the evaluation for. And step three is, of course, it's the general information about NBS. It's very case specific, so there needs to be some user input here. It can change according to NBS selected, and it can change also according to where NBS is being implemented. So we are asking about, first of all, the geographical location of the NBS project. And in the background, we have different data sets according to different locations. Of course, you can always go back and forward and change the information that you have entered with previous and next buttons here. And next comes the selection of the key performance indicators, the KPI. You can select them all. So you can see here the urban flow analysis indicators and the life cycle assessment indicators. So depending on the selection, following step is altered, and you will see the results only for the KPIs that you are selecting. The next step, after you select the KPIs, we are asking some more further information about the NBS project that you have. So here, this is the last user-based step to be filled according to the previously selected KPI necessities. So whichever KPI you have selected, the information is asked according to this KPI selection. All the required inputs with the defined metric unit are given here to help the user. We also have some text support. that you can go over this little asterisk here, and you can have some user support there. We have entered some default values that are common to NBS projects, but of course, every value is changeable, so you can play around with the values. You can change them as much as you want. So they are all modifiable. So with the last step of the user input, then comes the assessment results. The gray portion you see on the top of the page is a brief summary about the NBS in concern, including location, lifetime, type, and other relevant information. And then you can see the KPI results at the bottom of the screen. So this is a sample report page, which user can take a printout, they can save, review online, whichever way they would like to, save the results for themselves. So NBS in the form of tables together with some graphical representations is followed here. So we also have some graphical information about the results that you can also use in your reports, and they are of course more, maybe even more useful for the decision makers to see and review the results better than some random numerical values. So different types of visualization can be available, and they are ready for the user. So at the bottom of this page, you can see before and after scenarios, and as well as the gray solution. So it's important to understand in which context you are achieving some benefits. So it's important to compare your results with conventional solutions, gray solutions, or maybe you would like to select between different NBS and you want to see which NBS brings more benefits. So it's possible to do that. The comparison, scenario comparisons, is part of the environmental assessment tool. So finally, we also added the climate resilience assessment for the NBS. So there are decision support guidelines implemented in the platform. We have 3 basic steps here. The first step is to express your interest by answering 9 questions about in which context you would like to review the climate resilience. The second step is viewing a summary of the pre-selected methods. So you can go there and get informed about the methods already available. And the third step is viewing the forms with more information about the pre-selected models. So you can go into detail about specific methodologies and how to implement them.
Hello, everybody. So I'm Kirena Grassal from Novatech. Regarding the question about LCA, we actually build the stories based on real case studies, thanks to Nature4Cities partners. When we didn't have the data, we used existing inventories based on literature. But we prefer to based on real case studies when we could.
So the types of materials, they are kind of dependent on the NBS. For example, if this NBS needs some construction materials, we try to include those type of. So here, for example, we have included the materials for construction of the living wall system, as well as the materials and energy for the operation of the NBS as well. So like we may have, for example, for parks, urban parks, we may need some water for irrigation, we may need some soil conditioners or fertilizers for the landscaping. If we need some, for example, organic chemicals, herbicides for taking care of the plants. So we try to think about all these inputs and include them.
And is it at the city scale?
We determined three scales, the object scale, the neighborhood scale, and city scale. So it depends again on the NBS and how much impact it's creating throughout the city. So some NBS, they may have a smaller area of impact, or some NBS, they may have a larger impact on the overall city, for example. So for the benefits and the trade-offs, first we started by identifying them for each scale as much as possible. So it changed between NBS to NBS. Yes, the last question is yes. So we of course this is a very complementary study, the MFA study, urban metabolism, and the LCA. So we always thought about creating everything necessary for the life cycle assessment, you know, system boundaries. So we started from the cradle phase, and we try to go all the way to the gray phase. So it starts by all the raw materials necessary to build up, construct, or start the NBS, everything needed during the implementation period. And of course, if there is a decommissioning or end of life phase for the NBS, we also try to consider that. About selection of the flows, what we have done is something different. We started by identifying narratively the benefits and trade-offs. For example, if we have for the living wall system a positive impact of creating a carbon sink, then we introduced a flow of carbon sequestration to our list. If we have, for example, an impact, positive impact of insulation, that means the building energy demand is going to change. So in the operational phase, we need to include the flow of energy required for example, cooling energy demand into our flow. So this is how we selected the flows for the positive and negative impacts, let's say, throughout the life cycle of the NBS.
Yes, maybe if I can complement the answer of Özge, for the simplified LCA tool, we also, for the whole modeling, we selected all the flows that Özge is mentioning, but for the simplified tool on the platform, we selected the most contributing flows to the final impacts. So because we cannot have hundreds of flows to fill for the user, so we've really focused on the more important and the more significatively impacting.
Thank you for reminding me that. Just yes, in fact, the idea behind the headline indicators and the approach Piran has already told us right now, we are trying to make it feasible, especially the data collection phase in terms of, the data collection phase and the amount of time that is going to be spent for the assessment. So for that reason, we try to introduce different steps like simplified assessments, a more streamlined approach for the urban metabolism, and the more feasible way to introduce life cycle assessment, which can be complex for non-practitioners to complete effectively. So this kind of helped us to make it more accessible to non-expert users and expert users at the same time. Of course, there are many parameters that affect them. What we are trying to do is we are trying to conceptualize it. So the NBS type is a big umbrella. The location is a big umbrella because based on the location, we are going to see a lot of changes based on the requirements of the NBS and how NBS operates, how NBS performs. But also during the implementation phase, of course, there are many parameters that affect the success of NBS. So what if things go according to plan, what if not? So this is kind of why we try to introduce the dynamic assessment methodology to see how well we are behaving. So when, for example, if we see that we are not behaving well and this type of trend is not making us reach the target in the given time frame, then we are able to go back and analyze the situation and see what's changing within our NBS project that hinders us to reach the goals in time. But based on the parameters, as I said, these are, you know, big umbrellas of many different parameters that are interacting with each other. So maybe it's better to discuss them nature-based solution by nature-based solution. So what we try to achieve with NBM is to understand the factors that are affecting the NBM on a larger scale and within the light of the citizen behavior. So based on the historical data, for example, I have an example here at the right side of my screen. It's about urban heat wave mortality. So we have some information from the past incidences, and we have some information about what happens if, for example, nothing is done. What is the mortality rate? What type of, you know, citizen groups are more affected by it? And also we try to find some information about the impact of green roofs for combating the urban heat wave mortality. So we have, even though we may have some averages, we also can convert it to meaningful ranges to change the parameter. For example, we can change the share of green roofs in a given city. Of course, the city is a mathematical model. This is not a simulated real city. This is a mathematical conceptual city, but we can change the share of green roofs. We can share the effectiveness of decreasing the impact of the heat wave mortalities. So this type of changing one parameter, think about it like sliders that you want to change between, you know, good or bad, 100% to 0%. So this type of parameter change, when we simulate it, when the simulation runs, the mathematical simulation runs, with the impact of the constraints of our conceptual city, we can see how much the mortality changes. So it's like an exercise that you do on your computer before start implementing the NBS on a very large scale, on maybe a city scale. So this is how we think this may help the upscaling of NBS.